This is our last unit for Igneous Rocks, Unit 6B, and we're going to get into a little bit more detail about what's going on in magma chambers as these igneous rocks form. You're going to be watching 3 videos before you see me again, and I want to give you some questions to think about that I will address in the next video where you see me as you watch these 3 videos. There's a lot of information in these videos, so I want to give you some guidelines. First of all, here are the unit learning outcomes for Unit 6B, so go ahead and pause the video and write these down. The first video is one from the City College of San Francisco, and it's a long one. It's about 20 minutes long, and it goes over quite a bit of review from what we learned last week, which is how to classify rocks based on texture and composition. So this is going to be really good to get you ready for this week's lab, which is going to be doing the same thing, identifying rocks based on composition and texture. And it also is going to introduce you to Bowen's reaction series, which is a really powerful understanding of how minerals crystallize in a particular order when a magma is cooling. So I'd like you to think about and try to answer these questions as you're watching that section of the video. What is the chemical composition of magmas formed from melting the mantle? Why do you think these are called primitive magmas? You might have to do a little side investigating because she doesn't tell you that answer. As a primitive magma cools, what are the first 2 minerals to solidify? Are they felsic or mafic? As a primitive magma cools, what are the last few minerals to solidify? And are these felsic or mafic? What is crystal fractionation? She talks about this when she talks about Bowen's reaction series, but she doesn't really call it that. A little bit later in the video, she comes back to it. So think about these things while you're watching this video. Also, I want you to realize that in this week's lab, you do have a version of Bowen's reaction series, so you might even want to get that out and compare it to the one she's using in her video. And also, you do have an igneous rock chart, so maybe you want to pull that out and compare it to her igneous rock chart. And what I've done here is I've highlighted in yellow the rock names that we're going to be using in lab this week. There are names here that we're not going to look at: quartz monzonite, syenite, komatiite, scoria, tuff. We're not going to look at those because it's just too much to do in one week. We're going to just concentrate on the, let's see, there's 8 here. We're just going to concentrate on those 8 rocks. And we're going to look at a bunch of examples of each of them, but those are the 8 we're going to look at this week. Then you're going to look at a video that explains 3 ways that rocks melt. And actually, the City College of San Francisco video that I was just talking about also mentions how rocks melt. But this one does it in a little more detail. And here are some things to think about while you're watching that video. What is the geothermal gradient? What is the definition of that term? How does pressure change as one goes deeper into the earth? What conditions related to rocks do the solidus and liquidus lines represent? Where, in terms of plate tectonics, and why does decompression melting occur? Where and why does flux melting occur? And what is the third way that rocks can be partially melted? The third video is about partial melting. The questions I want you to think about here are these. Why do rocks undergo partial melting? Complete this sentence. Most of the magma generated on Earth is formed below the blank as a result of partial melting of the blank. Which minerals melt at a lower temperature, felsic or mafic? What composition of magma is produced from partial melting, rich in silica or poor in silica? Which really, if you think about it, rich in silica is felsic and poor in silica is mafic. So I'm just using some slightly different terms. What composition or compositions of rocks are formed directly from partial melting of ultramafic rocks? And ultramafic rocks are mantle rocks. And then how can granites and rhyolites form? So as I mentioned, we're getting deeper into understanding igneous rocks and igneous processes. This is our last week studying igneous rocks. So here are those 3 videos. I recommend you watch them in this order. Then we'll have the video called Rocks 6A.5, where I'll address all of these questions and touch on the things that were not touched on in these videos that I want to make sure you know for igneous rocks. See you in lab.